Let us talk about null pointer in C++. Let's get an idea about the null pointer with these two example codes. So this is one code that does not use null pointer, and this is one code that uses null pointer. So when you declare a pointer variable or when you create a pointer variable, and if you do not initialize it to have address of a normal variable, then what happens is, like normal variables, pointer variables also have some random value. We do not know what kind of value this ptr variable is going to store. It can be any random value. Suppose you have a long code and you somehow did not run any line that initializes ptr to a valid address. Maybe it was in some if condition or some else condition. Somehow the ptr remained uninitialized, and then you try to access star ptr. This can be problematic because it's memory address, and uninitialized pointers are called wild pointers, because when you have uninitialized pointer, it can be having any memory address, and if you try to access value at that memory address, it can cause segmentation fault, can crash your program, can give you some random value, anything can happen. So writing such a code is never a good idea. But you may have situations where you do not know the pointer value when you are creating a variable, right? Sometimes you would like to initialize this pointer, later you would like to initialize using some logic inside some if condition or something, right? So how do you handle those situations? For those purposes, we have null. Null is just a special value of a pointer variable, which means this pointer right now does not hold any valid memory address. Please note that null is not a valid memory address, and that's what null indicates. When you have a pointer variable for which you do not know the right address when you are creating it, you just initialize it as null to clearly indicate that this pointer right now holds an invalid memory address. And later, if you want to check whether the pointer holds a valid memory address or not, you can always put this condition first. Before you dereference, if you are not sure like this pointer is valid or not, you put this condition. If ptr is not null, then only dereference it. It's much better code, and this code shows the use of null. So the idea is this: if you create a pointer variable and if you do not know at the time of creation how to initialize it, then you always initialize it with null. Don't leave it as a wild pointer. Let's now understand how null is actually implemented. So the expression or representation of null is compiler dependent. It's not standard, but most of the compilers, they implement null as zero integer value. So zero is considered as a special integer value. When you initialize a pointer with zero value, it compiles fine. But it does not mean that you can initialize a pointer value with any other integer. If you try initializing a pointer with an integer, say 10, 20 or anything other than 0, you will get compiler error, cannot convert int to int star. This is int value and we are trying to convert it into int star, assign it to an int star. So that's why we get this error. But 0 is a special value reserved for null pointer. So null is simply a macro in C++, which is typically defined as 0. So it's again a typical implementation, not standard. And C++ 11 introduced null PTR. We will be talking about null PTR in the next video. Let's now talk about some applications of null and some interesting points. So the first application is, as we have discussed already, null pointers are used to initialize the pointer variables which do not have any valid memory address initially. You create a pointer, you don't know what address to store in this pointer, you initialize it with null. Don't leave it as a wild pointer. And before dereferencing pointers, always check whether the pointer is null or not, right? So this is the recommended practice to be used always. The second thing is, null pointers can also be used by functions to return some invalid output values. For example, if you are writing a function int fun, right, and this function is supposed to return an integer value, and in some corner cases you want to tell as a return value that something went wrong, right? So how would you return it? You will return an integer value, say you return -1, but -1 can be a valid output of that function, right? So you are mixing the valid output with error values. If you return an integer pointer, right, and what you can do is, if something goes wrong inside the function, you can return null to indicate that something has gone wrong. Otherwise you can return address of an integer value, right? So this way a function can clearly tell if I am returning null, it means something has gone wrong, otherwise I am going to return a valid address to an integer, right? It cannot happen by simply having the return type as int, because if you are writing the return type as int, you will have to return an int, and 0 can be a valid integer return type of any function, -1 or any number can be a valid return value, right? So null being a special pointer value helps in function returns also. The third application is data structures. When you implement data structures like linked list, trees, you see null a lot. See, an empty linked list is represented as null in C++, right? An empty tree, an empty binary search tree, they are represented as null, right? When you implement your own data structures. And if you consider linked list data structure, in linked list data structure, nodes are connected one after the other, and there can be any number of nodes. You don't know the size, you only have the address of first node. So how do you decide that you have reached end? What you do is you mark end as null, right? That's how you decide, okay, this is the end of the list, right? So null being a special pointer value can be helpful in many situations. Now some interesting points. One thing is null pointer converts to boolean value false. So you can use pointer variables when you are expecting a boolean value in an expression. For example, I can use pointer inside if condition. And if this pointer is null, then this will always evaluate to false, right? So if this is not null, then only it will evaluate to true, right? All the not null values, they always evaluate to true, and only null evaluates to false. So you can always just simply put the pointer variable, right? And if it is null, then you will have this condition as false, otherwise you will have true. So output of this program is this line is not going to be executed. You are not going to get anything printed, right? Because this is null. So we are not going to get inside this condition because this condition is false. If I write an else part, then that else part will execute in this code, right? Because this is null, so it will evaluate to false. We will come to else part. One minor thing that I have been taking all the examples of null pointers and integer pointers. A null pointer can be of any type. You can have a double pointer, a character pointer. In fact, the user defined data types, they can all have null pointer as a value. In this example, I have double pointer as null, I have character pointer as null. You can have any data type pointer as null.